Vince, start at the beginning.
Trigonometry is a study of triangles, more specifically right triangles. So let's start by creating a right triangle with a right angle. Okay, now that right angle, that means it has a 90-degree angle. I don't want to assume anything here. You probably won't see the 90 in the future. What you'll see is a box. So you'll know that that's a 90-degree angle. Even if it doesn't look like one, you're going to have to assume if you see that box, it's a 90-degree angle. Then, of course, we need a third side.
I know that, dude.
Okay? Now, we'll need to be able to discuss these sides. The two sides that make up the right angle we'll call the legs. The other side
Excuse me, Professor Brain
has a fancy name called a hypotenuse. Okay? You'll need to know that. Right away, we're going to start talking about right triangles, including a gentleman known as Pythagoras. Now, Pythagoras lived back in the Greek days, so I don't have a great picture of him. This is as good as I could come up with. Back in the days of ancient Greece, the Greeks were known for being big partiers, and Pythagoras would have none of it. So he spent his time not at the parties, but rather sitting around, drawing in the dirt, and trying to come up with inventions, basically, mathematical inventions. And so the legend goes, one day he was drawing on a hill, and actually he was drawing a window. It was a square window of sides A plus B. Now recall that a square has the same sides, okay, same length as width. Okay, and he was trying to construct a window for a friend. And of course he connected the points there to create panes for the window. And then he thought, well, I'll make it fancier, and he drew a couple more lines. And he had this picture. Now, he was looking at this picture that day, and he looked at it over and over again, and he noticed that it was broken into two squares. A smaller square that was area A times A, or A squared, plus a larger square that was area B times B, or B squared. Okay. Oh, and also 4 right triangles of sides A, B, and C. You see the 4 of them? Now he did that over and over again.
Prepare to be astonished.
Then the next day, his friend talked him into going to the party. And you know what? He had a few. And he tried to redraw that same window. But this time, since he had had a few, and he wasn't very good with partying, he flipped the A and the B. But he didn't notice he was in the same drawing because it was the same length. A plus B is the same as B plus A. Okay? And he reconnected, tried to draw the panes, and when he connected it, it looked like this. And he went, well, now I don't have the 2 squares, I have 1 square. And the area of that square, of course, is C squared, and I still have those 4 right triangles that I had before, don't I? Now he said to himself, what if I take away the 4 right triangles from the window? What am I left with? I'm left with that square of area C squared. Now I started with this blue square, and I took away the 4 right triangles, and I'm left with C squared. That's what he did the second day. And then he thought,
Are you pondering what I'm pondering?
what about the first day?
Oh, I can't take it anymore.
Hang in there. The first day, he started with the same window, the same blue window, took away the same 4 triangles. He started with the same thing. He took away the same thing, and he was left with a different shape, mind you. But he should be left with the same thing. So of course, there was way more to it, but he ended up figuring out that for any right triangle, only works for right triangles, A squared plus B squared will always equal C squared. Well, it's only a legend. But anyway, you get the idea. For instance, in this triangle, the legs squared, 3 squared plus 4 squared Does it equal 5 squared? Well, 3 squared is 9. 4 squared is 16.
Believe it or not.
Son of a gun, it always works. And you might think, well, geez, what good is this? Well,
What would you do with the brain if you had one?
well, if we have a side missing, we can use the Pythagorean theorem to find the third side without measuring it. For instance, in this case, if the legs are 1 and 2, we could find the hypotenuse. 1 plus 4, well, doesn't always come out even. What number squared is 5? There is a number. It's called the square root of 5. You know that. And it comes out to a number that, you could use your calculator to compute.
You just want $1 million?
And it becomes quite useful, doesn't it? Now, typically students say, oh, that's stupid, I'll just measure it. But recall that that 1 and that 2 may not be 1 inch or 1 foot. It may be 1 mile. And it may be across water or through space. So you wouldn't want to measure it, okay? It becomes very difficult to measure things across water. So this is very useful in navigation and all kinds of other applications. And we're going to be using it in our trigonometry.
Well, here's another nice mess you've got.
Now, it's not always exactly a squared plus b squared. For instance, in this one, we're going to solve for the leg. We're going to use the a squared plus b squared, but we're going to end up, I hope you appreciate, subtracting. Because if a squared plus b squared equals c squared, if we subtract a squared from both sides, the one we're looking for, the b squared will equal c squared minus a squared. Still simple. In this problem, we'll go 2 squared minus 1 squared, or 4 minus 1, and we'll get 3. Of course, that's what b squared is, right? So the actual leg will end up being the square root of 3. Okay, so sometimes you have to add when you're looking for the hypotenuse. Other times you'll have to subtract using the formula when you're looking for a leg. Okay?